In this video, I'm going to use an option that's on the spectrum processing dialog window on the test data property page that helps us to visually understand how quantification by XPS is performed. When we measure an amount of signal, what we do in order to quantify in terms of atomic concentration, what we do is we have to scale the signal according to the relative sensitivity of the photoemission peaks. That's physics. We have to scale with respect to a variation in intensity that is due to the escape depth that varies as a function of kinetic energy. So that's physics again, scattering of electrons as they leave an element and pass through the sample. That happens differently for different kinetic energies. So we have to adjust if we want to compare oxygen and carbon. They're at different kinetic energies, so escape depth is important. There's also the instrumental response. Often when we're measuring high resolution spectra in particular, the transmission function does vary as a function of kinetic energy, so we need to again adjust intensities to account for the transmission of the instrument. That is to say, the efficiency with which electrons leave the surface and are recorded. So to see this in action, what I'm going to do is select these two as they are, these two VAMAS blocks, and then press the Quant Scale button, because what this will do is it will use the information about the region and the relative sensitivity for these regions, and it will then scale the data accordingly. So pressing the button, what we see is these data are then adjusted so that the scale now corresponds to the intensity after these corrections have been applied. And we can see this more clearly if we use a button that's on the SIMS toolbar, and it's useful for SIMS data, but it happens to be quite useful in this instance. So if I press the button that says copy tile display to all, what it will do is the scale that's used to display the carbon 1s is now also used to display the oxygen 1s. So having done so, it's quite clear that there is a similarity in corrected intensity between the oxygen 1s and the carbon 1s. They're color coded here to indicate the different chemical states, and once we look at it in this way, you can see why when we perform quantification we can end up with the correct ratio based on two peak models. The original data would not give you that ratio, but after you've corrected for these relative sensitivity, escape depth and transmission, then you end up with a result that makes more physical sense.